9 seconds. Long enough for Usain Bolt to run 100 meters, for 40 babies to be born, or for 270 stars in our universe to die. A lot can happen in 9 seconds, from the human perspective that is. 9 seconds is an eternity on the quantum scale, or just the blink of an eye on the grand scale of the universe. And 9 seconds is just long enough to confound particle physicists searching for the neutron lifetime. The history of measurements of the neutron lifetime date back as far as 1951, and in all that time just 2 methods of measurement have been developed, the beam and the bottle. Now, as we're all well aware, subatomic particles undergo decay into other subatomic particles, and the neutron is no different. In fact, in a process known as beta decay, neutrons turn into protons, electrons, and antineutrinos. So, Team Beam tried to count the number of protons produced by a beam of neutrons passing through a volume in a certain time. Now, to picture this, imagine we can represent our neutrons by magical popcorn kernels, which can spontaneously, and in the absence of heat, pop into a piece of popcorn. Now, there's no way for us to know exactly which kernels will pop and when, but what we do know is that after a certain period of time, we should be left with some amount of popcorn. Now, by counting how many pieces of popcorn we have and knowing how many kernels we started with, we can work out how long on average it takes for a kernel to pop. On the other hand, Team Bottle tried to confine a large number of neutrons in space, and after a certain amount of time, count how many neutrons are remaining rather than the number of protons produced. And so this is another method for us to measure the neutron lifetime. And what should we expect? Well, if the neutron does in fact undergo beta decay into a proton, electron, and antineutrino, just like we think, then these two answers should be the same. And that was in fact the case until 2005. But since then, experimental techniques and statistical treatment of the data have improved so much that in fact the two methods are now discrepant. Team Beam now report a neutron lifetime 9 seconds longer than that of Team Bottle, causing absolute chaos within the particle physics community. And that's where the problem still stands to this day. Now, many theories have been put forward to try and explain this discrepancy, the most popular of which being an alternative decay path of the neutron into dark matter. So what this means is that when we're counting the pieces of popcorn in the beam experiment, we would actually be missing this alternative popping path, and so we'll be underestimating how many neutrons decay, causing us to record a longer neutron lifetime. Now, with experiments at ISIS looking to detect dark matter in the near future, we should soon be able to conduct experiments right here to investigate this persistent and unexplained problem that has tremendous consequences for our understanding of the particles, stars, and galaxies in our universe. And all this chaos just caused by a meager 9 seconds. What do 9 seconds mean to you? Think on it, and enjoy the other presentations. Popcorn, anyone?